projects. In this video, we are going to explain about the project entitled as Examining Customer Satisfaction through Transformer-Based Sentiment Analysis for Improving Bilingual E-Commerce Experiences. So before getting into the video, let me give you the brief description about the project. This study explores how transformer-based sentiment analysis can be used to evaluate customer satisfaction in bilingual e-commerce platforms. By analyzing customer reviews in multiple languages, the approach identifies sentiment patterns that influences user experience. The findings help e-commerce business improve personalization, trust, and overall service quality across bilingual user bases. Coming to the abstract, this study focuses on analyzing customer satisfaction in bilingual e-commerce platforms using transformer-based sentiment analysis models. With the rapid growth of online shopping across multilingual regions, understanding customers' feedback is more than one language has become essential. Transformer models such as BERT and its multilingual variants enable accurate sentiment detection by capturing contextual meaning across languages. The insights gained from this analysis help businesses improve user experience, service quality, and customer retention in bilingual e-commerce environment. Coming to the existing system for customer sentiment analysis in e-commerce largely rely on traditional machine learning techniques or basic natural language processing methods. This approaches often use manual feature extraction, bag of words, or lexicon-based methods which struggles to capture context, sarcasm, and complex linguistic patterns. Additionally, most existing systems are designed for a single language, making them inefficient for bilingual platforms. As a result, sentiment classification accuracy is low and customer feedback in different languages is often misinterpreted or ignored. Coming to the proposed system or base paper work, the proposed system leverages transformer-based models to perform advanced sentiment analysis on bilingual customer reviews. By using multilingual transformer architectures, the system can understand semantic context, language nuisance, and emotional tone across multiple languages simultaneously. This approach improves sentiment classification accuracy and provides deeper insights into customer satisfaction. The proposed system enables e-commerce business to make data-driven decisions, enhance personalization, and improve overall user experience for a diverse bilingual customer base. Coming to the dataset used in this project are selected to represent real-world customer opinions related to online shopping and product experiences. The online shopping 10 categories dataset contains customer reviews collected from e-commerce platforms and is organized into 10 distinct product categories such as electronics, clothing, and household items, with each review labeled as positive or negative. This structured dataset supports supervised sentiment analysis and helps identify customer satisfaction trends across different product domains. In contrast, the product social media dataset consists of product-related tests extracted from social media platforms, capturing informal, unstructured, and emotionally expressive user opinions. Together, these datasets enables a comprehensive analysis by combining structured e-commerce reviews with spontaneous social media feedback, offering deeper insights into customer sentiment and behavior. Coming to the novelty or extension or enhancement or improvement. As an extension to the proposed system, advanced techniques were incorporated to improve models' performance, interpretability, and usability. First, Smart ENN was applied to handle class imbalance in the dataset by combining oversampling and data cleaning, which enhanced the quality and balance of training data. To improve sentiment prediction accuracy, a hybrid BERT LSTM model was developed, leveraging Bird's contextual language understanding with LSTM's ability to capture sequential dependencies. In addition, ensemble models combining traditional machine learning and deep learning approaches were implemented to achieve more robust and reliable predictions. Furthermore, explainable AI techniques such as LIME and SHAP were integrated to interpret model predictions by identifying important features influencing sentiment classification. This improves transparency and trust in the system by helping users understand how decisions are made. Finally, a Flask-based user interface was developed, allowing users to input text for sentiment prediction and performance topic modeling using the trained models. This extension makes the system interactive, interpretable, and practical for real-world deployment. Coming to the flow of the work, first, we have data ingestion. The data ingestion model is responsible for collecting raw textual data from multiple sources such as CSV files, database, or APIs, validating the data by removing duplicates and missing entries and producing a structured data set for further processing. Next, pre-processing. The pre-processing module standardizes the text by converting it to lower cases, removing HTML tags, URLs, and non-printed characteristics, performing tokenization based on the selected models, encoding sentiment labels numerically, and generating sentiment polarity scores using NLTK Sentiment Intensive Analyzer. Next, embedings and vectorization. The embedings and vectorization module converts cleaned text into numerical representations using traditional methods such as bag of words and TF-IDF for classical machine learning models, as well as contextual embeddings like BERT and Electra for deep learning models. Next, data visualization. The data visualization module provides exploratory insights by plotting the distribution of sentiment classes and generating word clouds to highly frequently occurring terms across different sentiment categories. Next, data balancing. The data balancing module addresses class imbalance by applying the SMART technique to the training dataset, generalizing synthetic samples for minority classes to improve model generalization. Next, feature extraction and data splitting. The feature extraction and data splitting module prepares finer feature sets and divides the dataset into training and testing subsets, ensuring unbiased and reliable performance evaluation. Next, model training. The model training module builds baseline models including linear regression with SGD, SVM with SGD, random forest, XGBoost, BiLSTM, BERT, and Electra, and also trains extended models using smart balanced data such as BERT embeddings with LSTM, LSTM with GRU, and ensemble voting classifier. Next, evaluation. The evaluation module measures model performance using accuracy, precision, recall, and FN score, analyze confusion metrics to identify false positives and false negatives, and applies explainable AI techniques such as LIME and SHAP to interpret model prediction. Next, model saving. The model saving module preserves the best performing classical models in .joblib format and deep learning models in .pt or .h5 format for deployment and future use. Next, Flask deployment. The Flask deployment module provides a web-based interface that accepts user input text, applies pre-processing and embedding steps, loads the trained model, predicts the sentiment class along with confidence scores, performing topic modeling to extract key terms and displaying the final results to the user. The algorithms used in the project are baseline models, linear regression with SGD, SVM with SGD, random forest, XGBoost, random forest plus XGBoost, BiLSTM, Electra, and BERT. As an extension, we have done with smart sampling data. We used BERT embedding with LSTM, LSTM plus GRU, and a voting classifier which consists of gradient boost plus XGBoost plus light GBM plus cat boost. Coming to the requirements, we have both hardware requirements and software requirements. Hardware requirements consisting of operating systems Windows only, processor i5 and above, RAM 8 GB and above, hard disk 25 GB and above. Software requirements consist of application framework is Anaconda, primary language is Python, front-end framework is Flask, backend is Jupyter Notebook, database is SQLite 3, technologies which we use to build the front-end are HTML, CSS, JavaScript and Bootstrap 4. To execute this project first, we need to open the code folder which contains the project source code files. This folder is a complete package of your project's code base containing everything needed to develop, test and deploy your application or model. Static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. Templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represents different pages of the website. App.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are the model files which contain algorithm information which will be loaded into the project code during the runtime. .ipynb files. These are the Jupyter Notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute the code in individual cells, making it a popular choice for data science. Signup.db file. This file is a database file used to store the user information. Now, coming to the execution of the project, first, you need to copy the path of the code folder from the address bar of the file explorer. Then, open Anaconda prompt. Use the command cd followed by a space and then paste the copied path. This command is used to change the current directory to the code folder's path. Now, compile the app.py file using the command python space app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address with a port number of 5000. Copy the local link provided by the Flask framework and paste it into any web browser. I prefer Chrome. This is the home page of the project should now be displayed in the browser. This is a front-end built using Flask framework. In this page, we have Home button and Sign Up button. Now click on Sign Up button so that the logon HTML will be opened, where you need to give the details and create an account for user authentication like username, full name, mail ID, contact number, and a password. Then click on Create an account so that all the given details are stored in signup.db and the login.html will be opened, where we need to access the application by username and password. Now click on Sign In. The prediction page has been displayed. In this page, we have Analysis button, Graphs button, Notebooks button, and Logout button. Firstly, click on Analysis button so that the customer satisfaction prediction will be opened, where you need to upload your customer feedback text and get instant sentiment analysis with AI-powered insights. Now, let us enter the input and click on Analyze Sentiment so that the input text is pre-processed and output will be displayed as the sentiment analysis is positive, product category is computer, topic analysis is topic 1. Here it is the original feedback text is given and the key points and the keywords are like good, effect, price, sound, performance, much, known, camera, buy. And we also have the detailed analysis like the sentiment details, category details, and topic details. Now click on Analyze Another Text. Again, the customer satisfaction predictor form will be opened where you need to enter the text. Now, let us enter the other input and check the output. Click on Analyze Sentiment. The analysis summary is given below, like the sentiment analysis is positive, product category is hotel, topic analysis is topic 1. We have the original feedback along with the key topic words, and we have the detail analysis like sentiment details, category details, and topic details. We also have one more button like download the results. By clicking this, the results have been downloaded. And next we have share the results. When you click on this, you can share the results. Now click on graphs button. As we have used two different data sets like dataset A and dataset B, we have two different category graphs. First, let us check with dataset A graphs. In this, first we have distribution of text lengths graph. The graph shows the most text samples at short in length with the highest frequency concentrated at a low number of words. As text length increases, the frequency drops sharply, indicating a right square distribution with a few very long texts. Next, we have distribution of sentiment labs graph. The graph shows that the dataset contains nearly equal number of positive and negative sentiment samples, indicating a well-balanced class distribution. This balance helps reduce model bias and allows sentiment classifiers to learn both classes effectively. Next, we have overall word cloud graph. The word cloud highlights the most frequently occurring words in the clean text, where larger word indicates higher frequency. It provides a quick visual summary of dominant terms and overall themes present in the dataset. Next, we have confusion matrix graph. The confusion matrix shows that the random forest and XGBoost soft opening model correctly classifies most positives and negative samples, indicating strong overall performance. Very few misclassification occurs with only 9 false positive and 51 false negative. Very few misclassifications occur with only 9 false negatives and 51 false positives, demonstrating high accuracy and reliability of the model. Next, we have accuracy comparison graph. The graph compares the accuracy of different machine learning and deep learning models using for sentiment classification. While most models achieve high accuracy, the voting classifier performs the best, indicating that ensemble learning improves overall prediction performance. Next, we have precision graph. The graph shows a comparison of precision scores across different machine learning and deep learning models for sentiment classification. Most models demonstrate high precision, with the voting classifier achieving the highest value, indicating fewer false positive predictions. Next, we have recall comparison graph. The bar chart compares the recall of different machine learning models. Deep learning models like BERT LSTM, Electra, YLSTM, LSTM plus GRU generally perform very well, while traditional models like Random Forest, XGBoost, Random Forest plus XGBoost have slightly lower recall. The voting classifier achieves the highest recall, indicating it best identifies relevant instance. Next, we have F1 score graph. The bar chart compares the F1 scores of different machine learning models. It shows that most models including BERT, LSTM, Electra, and BiLSTM achieve high F1 score around 0.92% to 0.94%, while traditional models like Random Forest and XGBoost perform slightly lower, with the ensemble voting classifier achieving the highest score close to 0.98%. Next, we have explainable Sharpe graph. This is a Sharpe summary plot showing how different words influence the model's prediction. Each dot shows a word impact. Points to the right increase the prediction, to the left decrease it, and color shows low to high feature values. Most words cluster near zero, meaning they have little effect, while a few words have stronger positive or negative influence. Next, we have distribution of categories graph. This bar chart shows the number of samples in each product category. Some categories have very high and equal count, while others have much fewer samples. Overall, the dataset is imbalanced across categories. Next, we have BERT and Electra model performance graph. In this, first we have accuracy score graph. The bar chart compares the accuracy of two models, BERT and Electra. Both models achieve very high and similar accuracy, with birth performing slightly better. Overall, the performance difference between the two models is minimal. Next, we have precision score graph. The graph compares the precision of two machine learning models, BERT and Electra. Both models achieve very high precision, indicating strong performance, with BERT performing slightly better than Electra. Next, we have recall graph. The graph compares the recall of BERT and Electra models. Both models show very high recall, meaning they successfully identify most relevant cases, with BERT performing slightly better than Electra. Next, we have FN score graph. The graph compares the FN scores of BERT and Electra, which combines precision and recall into a single matrix. Both models perform very well overall, with both achieving a slightly higher FN score than Electra, indicating more balanced performance. Now, let us check the dataset B graphs. In this, first we have distribution of text length graphs. The histogram shows how often different text languages. The histogram shows how often different length text occur. Most texts are short, clustering around 5 to 25 words, with frequency decreasing as the word count increases. This creates a right square distribution indicating fewer very long texts. Next, we have overall word cloud graph. This word cloud shows the most frequent words in the clean text, where larger words appear more often. Terms like the, to, and be dominate, indicating they are most commonly used. Overall, it highlights the key vocabulary and repetition patterns in the dataset. Next, we have distribution of sentiment graph. The bar chart shows the distribution of sentiment labels in the dataset. Negative sentiments occur more frequently than positive ones, indicating an imbalance. This suggests the dataset contains a higher proportion of negative text samples. Next, we have confusion matrix graph. This confusion matrix shows how well the random forest plus XGBoost in soft opening model perform. It correctly predicts 388 negatives and 1238 positives, with only 13 false positives and 9 false negatives. Overall, the model has very high accuracy with very few misclassifications. Next, we have accuracy comparison graph. This bar chart compares the accuracy of different machine learning models. The voting classifier achieves the highest accuracy, followed closely by birth-based and ensemble models like random forest plus XGBoost. LSTM plus GRU perform slightly worse than the other models, showing the lowest accuracy. Next, we have precision graph. This bar chart compares the precision of different machine learning models. The voting classifier shows the highest precision, followed by birth-based and ensemble models, indicating fewer false positives. LSTM plus GRU performed poorly with significantly low precision than all other models. Next, we have recall score graph. The graph compares the recall scores of different machine learning models. Most models achieve highest recall, with the voting classifier and birth-based models performing best, while LSTM plus GRU shows significantly low recall. Next, we have FN score graph. The graph shows the FN score comparison of different machine learning models. Most models perform strongly with FN score above 0.9%, with the voting classifier achieving the highest score, while LSTM plus GRU perform significantly worse than others. And finally, we have explainable AI SHAP graph. This SHAP summary plot shows how individual words influence the model prediction. Words like bad, poor, and regret have stronger negative SHAP values, pushing predictions towards negative sentiment, while words such as good pushes prediction towards positive sentiment. Now, click on log out. So finally, the project demonstrates that transformer-based sentiment analysis can effectively capture customers' opinion in both English and the targeted bilingual language, providing deep insights into satisfaction trends. By analyzing these sentiments, e-commerce platforms can identify pain points enhancing user experience and tailor service to meet diverse customer needs. Overall, this approach offers a data driven strategy for improving engagement, loyalty, and sales in bilingual e commerce markets. So, this is all about your project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.